Climate change could be tackled by algorithms. AI is revolutionizing climate change research in unconventional ways. By analyzing vast datasets, AI predicts weather patterns with over 90% accuracy, enabling tailored solutions for local ecosystems. Machine learning models are being used to simulate carbon emissions and impacts, projecting future scenarios with 80% reliability. In 2022 alone, these technologies helped identify over 800 new renewable energy sites, drastically shifting energy strategies. Additionally, AI optimizes resource allocation and conservation efforts, enhancing biodiversity monitoring by 75%. The marriage of technology and climate science is not just effective, it's necessary for a sustainable future. This introductory paragraph serves as a springboard into the fascinating realm where artificial intelligence intersects with the urgent need for climate action. Artificial intelligence is proving to be a game changer in predicting weather patterns, a crucial aspect of understanding and combating climate change. Traditional weather forecasting methods, while useful, often lack the precision and long-term forecasting capabilities that AI brings to the table. AI algorithms, particularly those employing machine learning, thrive on data. These algorithms are fed massive datasets of historical weather data, atmospheric conditions, and even oceanic currents. This data-driven approach allows AI to identify subtle patterns and correlations that might escape traditional forecasting models. Consequently, AI can predict weather events with remarkable accuracy, often exceeding 90%, and provide insights into long-term climate trends. Understanding and mitigating climate change necessitate a thorough grasp of carbon emissions and their impact. Machine learning models have emerged as powerful tools for simulating carbon footprints across various sectors and predicting their future implications. These models are trained on extensive datasets of past and present emissions data, economic activity, and energy consumption patterns. By analyzing these variables, AI can project future emissions scenarios with a high degree of reliability, often exceeding 80%, under different policy and economic growth scenarios. These simulations are instrumental in informing policy decisions, guiding investments in renewable energy, and developing effective strategies for emissions reduction. The transition to a sustainable future hinges on our ability to harness renewable energy sources effectively. In 2022 alone, AI played a pivotal role in identifying over 800 new sites suitable for wind, solar, and geothermal energy generation. This impressive feat underscores the transformative potential of AI in accelerating the adoption of renewable energy on a global scale. AI's ability to analyze vast datasets of geographical information, weather patterns, and energy consumption patterns proves invaluable in pinpointing optimal locations for renewable energy installations. This targeted approach maximizes energy generation potential while minimizing environmental impact and infrastructural challenges. Section 5. Optimizing conservation efforts with AI. Conservation efforts are often hampered by limited resources and the vastness of areas that require monitoring. Artificial intelligence offers a robust solution by optimizing resource allocation and enhancing the effectiveness of conservation initiatives. AI algorithms can analyze data from various sources, including satellite imagery, wildlife tracking sensors, and climate models, to identify areas most in need of conservation intervention. This data-driven approach ensures that resources are directed where they are most impactful, maximizing the protection of endangered species and their habitats. Section 6. AI, the watchful eye on biodiversity. Biodiversity, the intricate web of life on Earth, is facing unprecedented threats due to climate change and habitat loss. Monitoring biodiversity is crucial for understanding these threats and implementing effective conservation measures. Artificial intelligence is proving to be an invaluable tool in this domain, enhancing biodiversity monitoring by an impressive 75%. AI-powered tools such as camera traps equipped with image recognition software, acoustic sensors for identifying species by their calls, and drones for aerial surveys are revolutionizing data collection in biodiversity hotspots. These technologies generate vast amounts of data that would be impossible to analyze manually. AI steps in to process this data, identifying individual animals, tracking their movements, and detecting changes in population dynamics. Section 7. The ethical considerations of AI in climate action. As we increasingly rely on AI for climate change research and action, it's essential to address the ethical considerations surrounding its use. AI algorithms are only as good as the data they are trained on, and biases in data can lead to biased outcomes. For instance, if AI models are trained on data that underrepresents certain geographical regions or communities, the resulting climate solutions may not be equitable or effective for all. Furthermore, the deployment of AI in conservation efforts raises concerns about surveillance and potential disruptions to wildlife. Striking a balance between leveraging AI's capabilities and addressing its ethical implications is crucial for ensuring responsible and just climate action. Section 8. Overcoming challenges, data bias and accessibility. While AI holds immense promise for climate change research and action, several challenges must be addressed to fully realize its potential. One significant hurdle is data bias, which can arise from incomplete data sets, historical inaccuracies, or a lack of representation from certain regions or communities. AI models trained on biased data can perpetuate these biases, leading to skewed predictions and potentially harmful outcomes. Another challenge is data accessibility. Climate data is often scattered across various institutions, organizations, and government agencies, making it challenging to compile and analyze efficiently. Improved data sharing and collaboration are essential for unlocking the full potential of AI in climate change research. Section 9. Conclusion. A sustainable future powered by AI. The integration of artificial intelligence with climate science is not merely a technological advancement, it's a necessary step towards a sustainable future. AI's ability to analyze complex datasets, predict future scenarios, and optimize resource allocation provides invaluable tools for understanding and mitigating climate change. From predicting weather patterns with unprecedented accuracy, to revolutionizing renewable energy exploration and enhancing biodiversity monitoring, AI is transforming the landscape of climate action. As we move forward, it's imperative to address the ethical considerations, data biases, and accessibility challenges associated with AI to ensure its responsible and equitable deployment. By harnessing the power of AI while remaining mindful of its limitations, we can pave the way for a future where technology and nature coexist in harmony.